Chapter 1, Lesson 3 is on solving equations with variables on both sides. Up to this point, we've done simple equations where it took one step to solve. We've done two-step and multi-step equations where we had to introduce simplifying our equations before we could complete solving them. And now we're going to expand it to where we can have the variable appear on both the left and the right. I have listed two Missouri state standards. First one states that I will be able to write and identify equations with one, infinitely many, or no solutions. Now that part is going to be new. Every equation we have worked with has had exactly one solution. We're going to introduce the idea of there being an infinite number of possible answers or equations that are not true, meaning there is no solution. And this also ties into the standard that states I will be able to solve equations in one variable. So we're still working in one variable, but now we're going to put the variable on both the left and the right side. To solve equations with variables on both sides, collect the variable terms on one side and the constant terms on the other side. We've practiced this before, where we had to use addition or subtraction to move the constant away from the variable off to the other side. We will have to do that with not just the constant term, but the variable terms. And we're still going to be using addition or subtraction to perform that step. In a previous video, I had introduced the idea that equations can have upwards of 5 steps for our class. First one was to distribute. Second was to combine like terms. The third one, which we haven't used yet, is where we use addition or subtraction on the variable term. So that it is on one side of the equal sign. Once the variables are all collected on one side, then we do the same with the constant. And then we can go and complete our equation by dividing or multiplying by the coefficient. Today, you'll see examples where you use all or nearly all of the steps for solving an equation. Now, let's see how that applies with our first example on the left. Now, looking at the 5 steps, we do not have any use for the distribute step here. And remember that with equations, even though there's 5 possible steps I've laid out, you will probably not use all of them for most of the equations that you solve. In this case, I don't need to distribute because there are no parentheses. If I look at my equation as being a left side and a right side, over on the left, the 15 and the negative 2x, there's nothing for me to combine there. And on the right side, there's a negative 7x, but nothing else. So we don't have combining like terms here. We do have x appearing on both sides of the equal sign. So we need to use step 3, where we are going to use either addition or subtraction to move the variable to one side. Our goal is that there's a variable on one side of the equal sign and some constant on the other. Because of that, I want you to notice that on the left, we have a constant and a variable term, where over here I only have a variable term on the right. So it would be in our best interest, the simplest step, to take the variable here from the left and move it over to the right side so that there's only a constant on the left and the variable on the right. So we're going to look at the negative 2x. To take the negative 2x and move it over to the right side, we do the opposite of a negative, or subtraction, which would be to add 2x to both sides of the equation. Over on the left side, by doing that, I'm only left with the 15. Because negative 2x plus 2x becomes just 0. And I now need to go ahead and combine negative 7x plus 2x. So if I owe my friends $7 and I give them $2, I still owe them $5. So negative 5x. Now, over here I have a constant. And on this side I have a variable term. So I'm almost at the end. I have one more step because the variable needs to be alone. The only number allowed to be in front of the variable is a positive 1. So I got to remove this negative 5. Now it says negative 5 times x. So I divide by negative 5 on both sides of the equal sign. The negative 5 divided by negative 5 reduces to 1x, leaving me with 15 divided by negative 5, which is negative 3. Ending our first example where x is on both sides of the equal sign. We're going to take a look at two more like this before adding in our distribution again. I want to get you used to just moving the x term back and forth. Then we'll add in the other steps. Pause if you need to so that you can go back and make sure you followed step by step. Let's look at the example on the left. So negative 3x equals 2x plus 20. Our goal here, again, is we want to have it to where it's a variable term on one side with the constant on the other. That's our goal. But I notice that I have a variable term on the left, but on the right I have a variable and a constant. So I need to take the variable on the right, move it to the left side, so that all the variables are on the left and the constants are on the right. That would be the least amount of steps necessary. So let's focus in on the 2x. That is a positive 2x. So if I want to move it over to the opposite side, I must use the opposite of a positive 2x. So we'll subtract 2x on both sides. On the right, I'm only left with a positive 20 because the 2x and negative 2x became 0. And I need to combine negative 3x minus 2x. So I owe my friend $3. They give me another $2, so I owe them now $5. So negative 5x equals 20. So my equation from earlier has now been transformed into a new yet equivalent equation. And now I can go ahead. I have my variable on the left, constant on the right. Let's get x away from the negative 5. It says negative 5 times x, so to undo, I would divide by negative 5. Negative 5 divided by negative 5 is just 1x. And then 20 divided by negative 5 is negative 4. We're going to increase the number of steps with this third example. In this third example, we're going to increase this from being just 2 steps to, I believe, about 3 steps. Let's start by looking at what is on each side of the equal sign. I see a variable term and a constant term. on the left. I see a variable term and a constant term on the right. So here's what I need to do. I need to take, this is an example. There's actually 4 different ways you could start this equation. But what I could do is take this variable and move it to the left, and this constant and move it to the right. And I would have all the variables on one side and constants on the other. That's one way. But it turns out what you could do, another way of looking at this, is you could move the variable from the left and the constant from the right and have a result that says a constant equals a variable. Both those are extremely valid. So let's just do one. I'm going to go with the first example. In that first example I made up here, I said, let's take the 4y or 4.5y and move it over to the 2.5. It's positive. So to move it to the opposite side, the opposite is a negative. On the right side, I have a -1 remaining. On the left side, I still have a +6, but I need to go ahead and simplify or combine together the 2.5y minus the 4.5y. If you have $2.50 and you want to buy something for $4.50, well, you need another $2 to make that work. And we are one step closer here, because now I have a variable on the left with a constant and a constant on the right. So this constant on the left is going to need to be moved over so that I only have a variable on the left and all my constants on the right. So I am going to focus in on the +6. If I want to move it to the opposite side, the opposite of a +6 is a -6. My -2y comes down. I have -1 minus 6. So you owe your friend $1. They let you borrow $6 more, so you now owe them $7. And now I'm left at the step that I need to get this -2. It says -2 times y. So to undo multiplication, I divide by -2. Be very careful, because a -7 divided by a -2 becomes +7/2. 7 cannot be divided evenly by 2. So we could leave it as a fraction, but it's also good to recognize what would this look like in other forms. You never know with multiple choice if they're going to give it to you as an improper fraction, a mixed number, or even a decimal. So as we get further along, I'm going to try to give you all the different answer types because you have to be able to recognize all of them as potential answers. We're going to move on to where you need the distributive property. Feel free to pause the video to get down any other information you might need, and then start it back up to join us as we apply the distributive property to our next example. This next example has parentheses, which means we need the distribute step. Negative 2 times x is negative 2x. Negative 2 times negative 5 is positive 10. Six times 2 is 12. And 6 times negative 0.5. 0.5 is the same as 1/2. And 1/2 of 6, this would be negative 3x. If we break this up, notice on the left I have a variable and a constant. On the right I have a constant and a variable. So we need to begin moving it so that all the variables are on one side, all the constants are on the other. And there's about 4 different ways I personally would go about solving this. I'm just going to pick one of them. And what I'm going to do is I'm going to take the minus 3x and I'm going to move it to the opposite side. I just picked one of them to go with, so I could do third step, which is going to be to add 3x to both sides. Now, negative 2x plus 3x gives me 1x. That's nice. That actually saves me a step. And I can bring down my plus 10. And on the right, I can bring my 12. Depending on how you start solving an equation, you could either create more steps you have to do, or you could simplify your equation in a way that you have fewer steps to perform than, say, your neighbor. Now again, I have variable and constant on the left, but only constant on the right. So we're going to take the plus 10, and we are going to move it to the opposite side using its opposite. So we're going to subtract 10 and subtract 10. And then 12 minus 10 equals 2. This equation could have gone very different if I would have started with the negative 2x. In fact, had you started by moving the negative 2x from left to right, you would have actually made this 4 steps instead of 3. You would not have been incorrect, it just creates a few extra pieces. Each of these examples have been an example of one solution equations. One solution equations are where we have a variable equals a constant. There's actually a way that you can recognize when you're going to have a one solution, and I'm going to go ahead and give you that hint. The hint would be that the variable has different or not equal coefficients. And we'll have more examples where we can talk about that. But I want you to go back and notice that the number in front of the variable was different on both sides of the equation on all of those examples. We're going to move along and take a look at what the other types of solutions we could get. Infinitely many, and no solution. There it is. So, our first example that we're going to look at is the no solution. And in a no solution, the left side does not actually equal the right side. For example, when trying to solve the equation, you could get something that says 3 equals negative 7. Well, if I have $3, that is not the same thing as owing my friend $7. And I'm going to go ahead and show you by solving the equation, or trying to, before I give you the hint as to what could be a giveaway, something that tells me whether or not this is one, no, or infinitely many solutions. Let's just try to solve this. On the left, I have a constant and a variable. And on the right, I have a constant and a variable. Here's something to notice. The coefficient on the variable terms are exactly the same. They both say negative 4x. The constants are different. So let's see what happens when we try to solve this. I'm going to take this negative 4x on the right, and I'm going to move it over to the opposite side. Well, the opposite of a negative 4x is to add 4x. When you try to combine two opposites like that, they become 0. And I'm left with a 3 on the left and a -7 on the right. I stated earlier, though, that 3 and -7 are not equal. So this is not true. Therefore, this equation has no solution. There is no number for x where the left and the right side are going to be equal to each other. There's just no way. And I actually gave you the hint earlier of what you could be looking for. If you look at an equation and you notice that the coefficient on the variable are the same, but the constants on each side are different, they're going to always have this result. Let's do one more, which is the infinitely many solutions. And we'll take a look at what's the same and what's different, because that could give me a hint as to what kind of answer we're going to have. Something to note is, so for infinitely many solutions, here's what's going to happen. You could have something that looks like 5 is equal to 5. It does not matter where you are. 5 is always 5. There's actually two things we could look for. Are the coefficients the same? And this time, are the constants the same? This is like the hint. The problem is we cannot decide this yet. Our previous example did not need this. But in order for us to actually look at that, we must distribute and combine first, before we can decide if the coefficients and the constants are the same. There's no way around that. If we can just do those two steps, you'll be able to determine how many solutions it has. In this example, I do have parentheses, so we need to go ahead and distribute the 4 and find out what this equation is going to look like. Now, off to the side here, 3 halves times 4. A couple ways you could think about this. I know 3 times 4, that would give me 12 over 2. 12 over 2 is 6. So I wind up with 6x. And then 4 times positive 1 is positive 4. And let's look at the left side, which has not changed. I just had to bring those down. Let us try the step where we try to get all of our variables onto one side. Because as we see, variable, constant, variable, constant. We're going to get all the variables to one side. If I take this plus 6, I know it's positive because there's no sign in front. If I do the opposite and subtract 6x and subtract 6x, well, when you add opposites, they become 0, and I am left with a positive 4 on the left and a positive 4 on the right. Four equals 4 is always true. And because of this, it does not matter what x is. X could be 5, x could be 5,000. No matter what, the left and the right will always be equal to each other. So we say it has infinitely many solutions. I could take an infinite number of people, and if they pick a different number for x, this equation is going to always be true. When I look at equations like this, I want to offer up to you a useful chart that might be able to help you better know your number of solutions. Pause if you need to, and then I'm going to scroll down and present to you that chart. So this is about the number of solutions. One solution, no solution, and infinitely many solutions. And for the chart, let's see. We have to consider the variable terms and the constant terms. And what we're going to look at is which ones are the same and which ones are different. Now, if the variable terms are different, it's going to be one solution. It does not even matter what the constants are. If the variables have different coefficients, it's always going to be one solution. If the variable terms are equal, but the constant terms are not the same, we're looking at a no solution. And then for infinitely many, the variable terms will be the same and the constant terms will be the same. We'll see this again when we talk about a later unit where we talk about systems of equations, because this can be a helpful tool in identifying one solution, no solution, and infinitely many solutions for not just solving equations, but graphing a system of equations. Pause if you want to copy this down, and then move on to 2 examples for you to try out. There they are. I have 2 examples here. Pause the video to try them out, and then turn it back on, and you will see the solutions in front of you. I'm not going to narrate this time.